Hello, everybody. Welcome to the live stream. Um, I wanted to talk a little bit today about the Boeing Starliner that is about to return from space, and a couple of other things that I have uh, come across my radar screen in the last couple of weeks/months, especially when it comes to how we behave when it comes to scientists and science in general. So the Boeing Starliner is making a bunch of news and has for a while, mostly because it got to space and it couldn't quite figure out how to get home. Right? It took a couple of scientists or a couple of astronauts. I do apologize. Over to the International Space Station, and it couldn't get them back. So the intent was for them to be up there for about 10 days, and so far they've been up there for over like 80. They uh, the challenge has been when they went to dock with the space station, it uh, it didn't quite go well. So as they were trying to dock, there were five thrusters I think that were out. They had a helium leak. Um, it was interesting to try to dock it apparently, and they've been running all kinds of tests and they've run all kinds of little challenges. Um, it Since that time, and they've deemed it unsafe to return with humans on it. So today, at some point, it may have already happened. They're going to bring it back to Earth and say, "Okay, we're done." The astronauts are not stranded there; they can get back. It is possible. In fact, SpaceX was about to send up sends up four astronauts. They're only going to send up two, and the other two will return home with the SpaceX crew in February, I believe. So they've got a couple more months to spend up there. Apologies. So the point is that they can get home safe, and this Boeing capsule is not going to be their ride home. It's going to be SpaceX. Now, why might this have occurred? Well, number one, obviously some flaws in the Boeing system. Obviously, it had some challenges. Do they trust it to come home? Well, they're bringing it home, so this will be the ultimate test, right? Whether it blows up or comes back or leaks or whatever as it comes back through the atmosphere, we'll find out whether or not it would have been safe for humans. But with space being space and reentry being reentry, if you have to take a chance, you don't, right? You find any alternative around it. So they're not using that to come home. They're going to be using a ride from SpaceX, which I find kind of interesting in ways that we couldn't quite get it done with this capsule. I get it. Space travel stuff. You gotta take your shots where you can. By the way, if you're watching this through any of the other platforms, because I'm live streaming kind of everywhere, the only place I see your comments is over on the YouTube channel. So if you bounce over there, it's just at Timothy M. Holton. You want to comment or ask a question, I can do it from there. But anywhere else, I'm probably not going to see it. So the interesting bit about this though is this is kind of a one-off. It's like, hey, look, are we actually going to trust Boeing to do this stuff again? And Boeing is sort of my segue into what I really wanted to talk about. I've been a scientist for a lot of years. I got my PhD more than 20 years ago now. And of course, time as an undergraduate and a graduate student, and most of my living has not been earned as a scientist. It's been as an engineer, but I'm really a scientist at heart. I spent a long time, and it depends on how you count it. So I spent a long time as a scientist at a university, but I spent probably just as much time as an engineer outside of universities, and those two things are kind of sort of related. Science is, especially physics, is sort of the basis for all kinds of other engineering disciplines. Although the engineers would probably argue that that's not true, but it really is. But the thing about this field of study or this field of making a living that I find interesting is the sort of public perception of scientists. And I would have never guessed this when I was a kid, because as a kid, I grew up watching PBS. I grew up watching documentaries. My dad was a software engineer from the early 60s until he retired in 2002. And when he passed away, he was a lifelong engineer who loved the sciences. But I grew up watching all kinds of things from the educational TV side, because that's kind of what my dad watched. And I'm going to add somebody to the stage. Hey, Dad, welcome.
Hello.
So we just talked about the Boeing Starliner, and the challenges that it has because it's coming back without humans. It's coming back all on its own. And the astronauts are going to catch a ride with SpaceX in February. But I was moving on to something else because one of the it's good timing to join. So thank you for that. What I was going to say is being a scientist, and you work with me, right? So Doug works at for my company, which is One for All Social. He's our ops guy. I'm our chief technology officer. And if you need a social media tool, it's o4a.com. It's great stuff. You get 2 months for free. And Doug will send you emails saying, "Hey, let me help you set your system up." So you'll see him. But the point is, when I was growing up as a kid in the '80s, I didn't play football, I didn't play baseball, I didn't do any of that other stuff. I was sort of the techno nerd. So I grew up watching a lot of PBS. And I think even if you weren't a techno nerd and you watch football, you probably still knew who this guy was, right? Carl Sagan was sort of everywhere. And the thing I loved about watching Carl Sagan stuff is that he could tell you about a quasar for the 35th time that day and still make it seem like he was fascinated by it, because I swear to God he was. He wasn't just sort of like, "Oh yeah, let me tell you about the moon." Right? I taught astronomy for a couple of semesters, and even I got to the point where I was like, "Yeah, Saturn is this," and because I've explained it so many times. He didn't suffer from that because he truly loved the field so much. And now that I'm a little bit older, I am sort of back to where I'm fascinated by it more than when I was sort of doing it for the 12th time that day. Maybe that'll change someday, but anyway. So he was sort of one of those pioneers, and there was another guy that that was around and still is. He still is kicking. That really kind of caught my attention when I was a kid. It was this guy James Burke, who had the show called Connections, which he's in his 80s is still doing on a channel, and he still does a lot of other stuff. But he was sort of a science reporter or science historian or science educator, and he would have this way of saying, "Let's go look at what happened in the Middle Ages and how it influenced how we got to MRIs or something." And he was really good at doing that sort of stuff. So he showed this connection between everything. That's the name of the show, Connections. But somewhere in between Carl and James, we've gotten to a world now where, I will never forget, I was at a conference probably 15 years ago, and I was at a dinner at this engineering conference, and I was with my now ex-wife, and somebody started asking a bunch of questions of her. She's a chemical engineer, and I turned and answered one of them, and she's like, "Don't listen to him. He's just a scientist." And a table of engineers was like, "Oh, okay." And I was like, "What the hell, man? Okay." But we'll kind of let that part go because me dishing on my ex-wife, and that part doesn't matter. But that attitude, I think, is interesting because, or not interesting, I think it's sort of dangerous, because occasionally on some of the social media sites, I will post pictures and or post comments or something about scientific topics, and I'll end up having to block people, because we've gotten to a point where we are the most technologically advanced society that the world has ever known, yet fewer people understand the technology, and more people are afraid of it and kind of skeptical about the people who understand it than ever before, right? So I put this new camera setup on, and when I look at myself, I'm looking at a weird angle, so I do apologize. I'm not used to it yet. But the point is that when these guys were around and these guys were sort of kicking and kind of on TV all the time and people were watching, I think we were more accepting of science. We were more like, okay, scientists are great guys. And now when I post stuff, it's like, well, all scientists lie. All scientists go for the research money. All scientists are just going to say what their funding tells them to say. And I'm like, that's not necessary. I've known a lot of scientists in my career. I worked at MIT for like 12 years. And I guarantee you those guys will say what's right, even if it costs them funding, because they'll go find funding somewhere else. Now, does that mean some scientists do that? I'm sure there are some, but let's put it another way. Like, I used to be married, and obviously I'm not for some reason. Would I hold what happened in that case against every other woman? Well, that wife lied, therefore all women lie, right? You can't do that, right? So I've had people tell me that all science, and not legitimately like come after me and say all scientists need to be put into warehouses, and we need to, they need to be monitored carefully for any dangerous activities because, well, COVID, right? And there we go. And it's just COVID. And it's always insert political rant here. And the more recent one was I posted something about that Carl Sagan, this guy right here, did. He testified in front of Congress, and he was talking about the greenhouse effect. And Doug, I'd love to hear your take on this, because he approached it very interestingly. He was very much the vehement scientist, and even on his deathbed, he was like, he was an atheist. He was like, I've seen no evidence of God. I don't, it is what it is. And he had a fatal disease, and he had it for years. He was in remission, but he was one of those, show me proof and I'll believe you kind of people. Not give me faith or give me sort of, wishy-washy stuff and I'll believe you. But he went into a great length to talk about the greenhouse effect. And he pointed out that our atmosphere naturally, even without human intervention, has a greenhouse effect. Because if it didn't, we would be about 30 degrees colder than we are right now, which would mean 30 plus degrees centigrade, not Fahrenheit, centigrade, colder than we are right now, which means at some point the oceans would freeze, the Great Lakes would be a chunk of ice, and there would be no life on this planet if there was no greenhouse effect. Now, too little greenhouse effect means we all die. That greenhouse effect is brought about because of carbon dioxide and carbon monoxide and all these things that come about when you burn fossil fuels. And if you make that greenhouse effect too big, we all die. So there's a little band in there that's very specific that we have to stay within. And he's like, too little, it's bad. Too much, it's bad. How much have we influenced it? He's like, that's a good question. We have to go back and actually scientifically figure that out. And I posted that, and there were some people that I had to very quickly block, because it turned out that apparently now I'm saying that man-made global warming is not an existential threat. And there was also the other side going, oh, you're one of those, you believe in man-made global warming. I'm like, I believe in I'm like, I just posted a thing at Carl Sagan. I didn't do anything in the middle, right? But a bunch of people came after me as being on both sides of it, and I wound up blocking people on both sides because it just got atrocious. One person was like, with your last name, I can find you. I'm like, yeah, it's not hard. My last name's pretty unique. I'm probably related to all of them in the country, or at least close to it. So, Doug, you live in a university town, and I'm hoping you don't see it as bad up there, but it seems to me like we've gotten to the point where we just have this innate distrust of science as a society, because it might not tell us the comfortable answer. The trouble is, science doesn't care what you want to hear. It says, here's an answer. You may not like it, but that is the scientific answer.
Well, my experience is a little different because I didn't grow up here, really. I've only resided here in North Texas for like the last 5 years now. But prior to that, I was exposed to Sagan through Cosmos, the TV show, and I was aware of him. And I was raised in a religious background. I'm not overly religious, but I am a Christian. But he did, which of course, in Neil deGrasse Tyson did it.
Yeah, now it's Neil deGrasse Tyson, who, I think he's done some interesting things. Carl Sagan, I would think, is a better scientist.
He really started
Neil that to his face. So.
Tyson just extrapolated upon his stuff and kind of rehosted the rebroadcast of the show. Right?
He's a legit astrophysicist. I will give him credit for that. But he is not. Carl Sagan had this ability to explain crazily complicated subjects in a very simple fashion, and to all of his credit for bringing science more mainstream, Neil deGrasse Tyson is not as good at it as Carl Sagan was. Sure. I think he probably has a bigger following than Carl would have at this point, and that's great, but I don't think he's as good at bringing it down to everybody's level. And
I mean, that's tough to compare to. You're talking about two different generations with different technology available at different times.
Absolutely. And to be fair, I've met Neil before, and I've kind of told him that to his face. So
there you go.
So, anybody who's coming at me going, "Oh, you wouldn't tell Neil that," actually, I kind of did. But
well, there you go. There you go.
He turned around and asked me how many followers I had, and I was like, "Well, okay, you do win that argument, but still."
But that's a misnomer when you're talking about the subject. To your question, it's not so. I mean, it is geographical, I think. And the reason I bring up my own belief, Christianity, and whatnot, is also I was also raised, that science is legitimate, and this is what has been studied and tested and true and tried, and these processes that scientists go through are what either validate or invalidate actual, fact. So while we have our belief, we don't just dismiss proven science. That being said. I don't know if I find it so much the university town, but I do find it so much more in the Bible Belt here that some people, a large majority of people in this area, are willing to throw science to the curb. Why? Because they have their belief in God. And I have a problem with that. I mean, and I'm a believer, but I have a problem with throwing proven scientific fact to the curb because of some higher power that you believe in that says that, it's not that way, it's this way. So, I mean, I lean towards going down the scientific aspect, but, we can't explain it all away. And there's just some things, that you have to go on faith. But, I'm going to put my intelligent mindset into what's proven, what's visible and provable and can be shown, right? I mean, as far as real life dealings.
Yeah. And like I had somebody come at me yesterday because, they were like, well, if science is so smart, how come we don't have a unified field theory? I'm like, because quantum mechanics is maybe 100 years old. And it wasn't until then we realized we were missing a unified field theory in the first place. And I'm sorry, even Einstein went to his deathbed trying to figure that one out. And what does that mean? Okay, so if you haven't seen it, it's a unified field theory. I have people come at me with that one all the time. And I'm like, okay, do you even understand what that is, right? Most people are like, yeah, it's the unified theory of physics. I'm like, yeah, great. You just repeated what you said, just using different words, right? So this is a James Webb Telescope image. So what this is called is the James Webb first deep field. So what they did was they picked a piece of space and said, stare at that for a while. And what you're seeing are tons of galaxies, essentially.
Right. Each one of those is a galaxy, right? From what I recall.
Yeah. Even the little tiny dots that look like a star is a galaxy because they went through and they removed everything else. But so every one of those could have multiple stars, multiple planets with life. And they're so far away that, based on known physics, how do we get there? The answer is never, but that's based on known physics. So what the unified field theory really is there's this in physics, and this is kind of what I've been doing with my YouTube channel is I would go through Nobel Prizes, and eventually I'm going to get to where we kind of talk about these more cutting edge topics because I want to give all their Nobel laureates their due because honestly, one of the things Hawking said that was absolutely right. Modern physics does stand on the shoulders of giants, absolute giants. You've got like Marie Curie. I mean, she discovered radium and everybody knows that, but did you know she was the first person, not woman, first person to win 2 Nobel Prizes? One in physics and one in chemistry. She won the one in chemistry like 2 years after she won the one in physics. So it was like just back to back. Her family had a total of 5. Her husband won one, shared with her in physics, and 2 of her kids won. Standing on the absolute shoulders of giants. You got Einstein, you've got Schroeder, you got all these other guys that won the prize. We actually learned a lot from, who gave us things like Einstein. Everybody thinks he won the prize for relativity, and it's not true. He actually won it for the photoelectric effect. And if you're curious, there's a video on my channel that shows that on YouTube. But the photoelectric effect is what lets solar cells work, grocery store scanners. And you go down the list, if it's turning photons into electrons, that's the photoelectric effect, and that's kind of what it's used for. So a lot of that science is now very well understood because we had these giants around the late 1800s, early 1900s that figured out that the atom is actually made up of other stuff, with protons, neutrons, and electrons. And then, somewhere after that, we figured out that even protons and neutrons are made up of other stuff called quarks, right? And, little tinier particles that are smaller than protons and neutrons. There's still debate whether or not the electron is a point particle or whether or not it's made up of stuff, but that's a whole nother story. And the point is, who cares about all that stuff? Well, okay, but who cared about the electron until we figured it out? Now we have electronics, right? So we figured out what to do with it, and it's because of these guys about 100 years ago that we figured all that out. And then they split the atom, and we figured out how to make everything from reactors to bombs. And we're still working on the fusion devices, but that's a whole different story. But the point is that the unified field theory sits somewhere in between the quantum mechanics side and the other side of life. So, and the reason the unified field theory, one of the many things that aren't completely understood that could lead to the unified field theory is gravity. Now, everybody knows I pick up my pen, I drop it, it's going to fall, right? We get that. It works. Why? We don't understand why. And if we could ever fully figure out gravitation, perhaps these distant stars ain't that distant anymore. That's the unified field. It's part of the unified field theory. Is if we could understand gravitation, maybe these interstellar distances ain't that bad. Maybe, possibly. There's a famous thing that showed up in Thor called the Einstein-Rosen bridge that now everybody lists a quote, go, oh, isn't that an Einstein-Rosen bridge? Well, okay, first off, the first time I ever heard it was in Contact, which was a Carl Sagan written movie. Great, Jodie Foster, if you should watch it.
Matthew McConaughey, I think, too, right?
Matthew McConaughey's in it. And actually, I couldn't find it streaming, and my daughter was into like any science topic. My daughter's 11, for those of you that don't know, and she's starting to get into any science topic, but she prefers stuff that has women in it because she's 11 and she's in 6th grade, and that's great. More power to you. And she actually was fascinated by that because Jodie Foster was the lead, right? And she's like, girls are teaching boys a lesson. I'm like, yeah, but she has boys around her that help. But yeah, she did more than they did. So I'm, you don't want to discredit that. Now my daughter's actually reading a biography on Marie Curie that was actually written by her daughter, Eve. And she's like a 6th grader that actually can't put down a biography. I thought it was pretty cool. But the point is that if we could understand that unified field theory, maybe we could solve this problem of interstellar distances, or maybe we could solve the problems that we face from an energy perspective. Maybe we can get away from fossil fuels by using something in the gravitational realm to generate power. Or maybe that could help us figure out fusion, because if you're not familiar with nuclear processes, when you look at nuclear reactors that create a lot of waste, those are fission reactors where you take a uranium atom and split it apart, and the two pieces are highly radioactive. When you use fusion, you're sticking two atoms together of hydrogen, and the byproduct is helium, but you also get a lot of energy. So if we can get that one to work, which is how the sun works, we'd be a lot better off. And that unified field theory could lead us to a lot of that kind of stuff, because we don't completely understand how to work down at that level yet. And we're getting there. But what's funny to me is when I mentioned, like, I actually kind of stopped for a while when I was out publicly telling people I'm a scientist, because number one, back to my whole topic of the day, number one, people were either like, oh, you're making that up. I was like, who the hell would make that up? Right? Is that like a pickup line that I'm not familiar with now? It's certainly never worked for me in the past. And the other one is there's always somebody with a half-baked theory about quantum teleportation and how we've got, manned colonies on Mars and all this other crap that the public doesn't know about. Or the other part of it is people become very suspicious of your motivations. Like, oh, you're just trying to cash in and do what your funding agents tell you to do. I'm like, I think anybody, and you can even ask Doug, have I ever been known because it was the guy writing the checks to just hold the same opinion as them?
No. I mean, you see a point of truth, you'll speak it out. And frankly, that's to your credit, because too many people are yes men in this world, in my opinion.
Data is data, right? And that's one of the things that drives me nuts when we all watch the news, is that scientists and mathematicians are now sort of like, oh, you need to sit down and be quiet and let the grown-ups handle it. Well, the trouble is a lot of our decisions are made on statistics, and a lot of times even I look at statistics and go, you guys are leaving a lot of shit out, right? You're just not handling it properly. So like, I'm not an economist, but I do understand math and I do understand statistics pretty well. We find the latest inflation numbers. So there's a lot of different inflation numbers, like CPI that burns around, that will give you these different numbers that you see quoted on the news, like this one, where it's, oh, look, inflation is coming down. We've got, all these, this is great. Look, we're down. Except it's, let's take food and energy out. And that's kind of what the numbers we're starting to see on the news are, oh, let's give you the inflation number, but let's take out food, energy, and the cost of living in your house because of repairs or property taxes or insurance. Strip all that stuff out. But hey, inflation's down, right? And then when the mathematician or the scientist stands up and goes, excuse me, 60+% of America lives paycheck to paycheck, and you want to take out food and energy so you can justify a rate cut. That seems kind of weird to me. And the other one is, I have a lot of people go, well, inflation is only, 4%. That's good. Okay. It was 6. Okay, what that means is prices ain't coming down; they're just not going up as fast, right? And when you try to explain that, people are like, "Oh, you don't understand." I'm like, "Okay, I don't, because it's still inflation. It's not deflation. It's still going up. It's not coming down. It's just not going up as quickly." And I get kind of shouted down because I'm like trying to explain the math, and people look at me like I'm, got two heads or something. I'm
Well,
like, you don't
I'm sure a lot of folks have their own personal interests on why they don't want you to speak the truth or speak the data you're finding.
ooh, real estate agents might be one of those, um, because we need those rates to come down so that your mortgage can be cheaper. Which I'm all for, making mortgages cheaper, but by the same token, maybe the price of the house has something to do with the fact that people aren't buying as often.
Mm.
Because we have a 20+% increase in house costs over the last 2-3 years or
I
something.
mean, it's crazy. I mean, you and I grew up in a time when it was the average, home price was supposed to be 3x your annual salary. Now it's 5, 6, 7x.
11 and a half is the going rate. So
I
yeah,
believe that you have that data more than I do. I'm just going off the top of my head. So
yeah. I actually ran the numbers in 1970, right around the time we went off the gold standard. The average home in the United States versus the average income in the United States was like 1.3 times each other. Now the average home versus the average income is 11.3 or 11.5, I think now. Um, but we're not on the gold standard anymore, which I find kind of unique, right? So I'm not sure those two things are connected, but they started to diverge right around that time. And it got worse in the 80s when we started really monkeying with the rates over at the Fed for political reasons. So, but what I find hilarious is that the local influencer gets to talk about it and be taken seriously, and the local scientists get told to shut up and sit down. Right? It's like, no, I understand statistics. Do you? Right? So, like, I'd explain it to a banker once, and they were trying to get me to sign a loan, and they weren't. They were trying to mask. They were trying to mask the interest rate for something. This goes back a couple of years. This was Doug. It was before I started working with you. It was I forget when, but it was a couple of years before I started working with you.
okay.
And they were trying to mask the interest rate on something. It was, I think it was a car dealer. And I was like, good Lord, what the hell's the interest rate on that? The guy's like, well, here's the payment. I'm like, okay, what are you charging me for the car? Well, this is the payment. And I was like, I worked it backwards in my head on the spot. And I'm like, okay, so either you're charging me like 18% or you're charging me a lot more than I think that car cost. And it turns out they were jacking up the price of the car because they were embedding extended warranties and all kinds of other maintenance projects. I'm like, dude, I don't want any of that crap. I thought I was clear. But everybody came very upset with the scientist because I was doing the math in my head, and they didn't believe it. And I'm like, let me get you a calculator, and I'll get the same answer, right? It's not going to matter. And yeah, but the ability to do that math, I think, pissed off that salesperson. But here I am walking in, actually able to tell they're full of crap, and I get shouted down, right? So I don't know. I think now let's go back to the other reason I wanted to do this discussion was one of the main reasons people threatened me on social media because I talk about science and scientists are not to be trusted was COVID. It's like, well, what they told us a bunch of lies during COVID. And what's hilarious to me is that there are people that are the vaccine supporters and the vaccine never touch me with it people who say the scientists lied. So let's talk about COVID for a second. Doug, your dad was a doctor, right?
Mm-hmm. Family practitioner, DO.
Family practitioner, right? So when you develop a new vaccine or a new treatment for something, how long does it normally take?
Oh, years. I mean, you got to go through testing. You got to go, internal testing, then external field testing with volunteers until you get FDA approval. So it's not like an overnight thing or even a year thing. I mean,
it's 6-7 years, right? It's
yeah.
5, 6, 7 years, easily 5 on a fast day. COVID, it was like, okay, guys, we need it on Friday, right? So scientists would come out, and we're going to leave Fauci out of this because Fauci was a politician for years with an MD behind his name. But legit scientists in the vaccine community were coming out going, we can't do this fast. The trouble was millions and millions of people were dying, especially elderly, all over the place, and we were all locked in our homes, and they had to come up with something fast. So they came up with this modified RNA thing that's sort of 80% effective, and you still get COVID, but you're not as sick. And COVID kind of became a thing of the past. And I think a lot of people are now going, yeah, those deaths were all faked. I'm like, what planet are you from? You think those deaths were all fake? But of course, you can't trust scientists because, well, Fauci said. But yeah, Fauci was going off of data that he had when they were trying to do stuff 100 times faster than they normally do. So one day to the next, the story might change, but that's because one day to the next, the data changed, right? So we don't have much data, but say something, right? So, well, I don't know, 50-50 odds, it's this. So let's go say that. Okay, well, 51-49 is this. And they eventually solidified it into a vaccine that kind of does keep us relatively healthy. There's a lot of skepticism about the long-term effects on it. But again, like what Doug just said, that's why it takes 5, 6, 7 years to test these things, is so that you can look at the long-term effects in laboratory mice instead of in humans. Because with white mice, you can go through generations of mice in a year, right? And with humans, it takes decades. So you can tell whether or not those long-term side effects are going to be there by injecting mice and just studying 4, 5, 6, 7 generations. You can't do that with humans, right? And there was sort of no choice. It was like, let's do something, right, and give it a shot.
Global pandemic, rush from God. I mean,
last time we had was what, the Black Plague or something, or killed like what, a third of the world or some weird thing before they figured out it was transmitted, I think, by fleas. I could have that wrong, but I think it was maybe rats or fleas or something. I don't know. So it was transmitted by something, and they just eventually figured out how to deal with that. But it, but we take that and then we say, oh well, let's go burn the scientists to the ground and tell them they're all wrong and they need to do better. I'm like, okay, but we also gave you the solar cell and space travel and 95 other things that you love, right? But oops, we made a mistake. It happens. And you can't count every scientist out just because some are willing to say, oh, look, the funding says this, therefore I need to go that direction. And I will tell you this, that in some level, there is some reasonable argument to be made that said scientists only work on what they can get funded. Well, no kidding, right? If the government funding says, hey, there's funding over here, a lot of scientists are going to go write proposals to try to
get you're in a communist country or a different country.
It's worse there. You know why it's a good point. So why the Russians have the best theoretical physicists in the world right now? They had no money to run experiments for decades, so they were just churning out theorists because there was nothing else they could do.
Okay,
pens and paper are cheap, right? You can do math all day, right? But trying to churn out an experiment on a cyclotron is millions upon millions of dollars, and the Russians didn't have the cash, so they did theory forever, and now they're some of the world's best theoretical physicists, and they're knocking everybody else out of the park on this stuff. But it's because there was no funding. So if you want scientists to work in areas that aren't directed by a government agenda, well, guess what? You got to put money in places that is undirected science. That's just the way it works.
Yeah.
And a lot of it tends to fall out of high risk military funding, honestly, because like the whole nuclear age came out of military funding, because the Manhattan Project, right? We had that, and it gave us nuclear weapons, but also gave us nuclear reactors. And if you're an if you don't want the greenhouse effect, nuclear works really well, and it doesn't produce any hydrocarbons. And okay, occasionally you get an accident, but how many people have died in coal mining accidents? A lot more than in nuclear reactor accidents. The worst of which was Chernobyl, and that was a very bad design that was not well maintained. And it was, done in the 60s now, so it's an 80-year-old design these days.
Something like that, yeah, the 60s. Yeah.
Yeah. So, the Navy puts them on boats, right? And I'm sorry, Navy folks, ships. I was Army. I understand. I got that wrong. But the Navy puts them on ships and drives them around the ocean. They haven't had an accident since the 60s. I think they had a sub that had an accident. I know the Russians had a couple subs that had accidents, but it's built properly with the right safety stuff. Nuclear is not that bad. And if you really wanted to get away from hydrocarbons, pour tons of money at fusion research, and that's the big hit, right? Because solar cells are great, solar cells are grand, and one fusion reactor, the sun works really well and produces a lot of energy, and if we could compass that here on the planet, on Earth, that'd be a big deal. But there's 3-4 maybe fusion research facilities in the country.
Yeah, today I don't know.
I used to work at one. It was the tokamak reactor at MIT. Like Cal Berkeley's got one. There's the Inertial Confinement Center. I think Los Alamos has one. So I think there's maybe 4. I'm probably missing a couple, but there's fusion research that goes around, but there's only a couple places where you're actually licensed to go off and create fusion reactions without potentially causing problems, because nobody really wants an unlicensed nuclear accelerator on their back in New York City. Come on, Ghostbusters. Sorry.
Run around New York with that on your back. Unlike the proton accelerator.
Well, little things. It's really just a high. You know what it means when he said that? It means they were using hydrogen atoms to capture the ghost. So proton is just essentially sort of a scientific way of saying hydrogen, because it only has one proton. And if you're accelerating protons, what you're doing is using hydrogen and stripping the electron off and accelerating a proton out to go do something. And proton beams, I've seen proton reactions. They don't look like what Ghostbusters have, but it was a good movie. I liked it. I've seen all of them, including the more recent one in New York. I thought it was pretty good. It wasn't as good as the original, but how do you say?
No, it wasn't as good. I actually liked Afterlife better than the most recent one, but we're getting off course. The recent one was good though. But I think it died in the editing. I think it could have been better if it wasn't so chopped down.
Probably so. But it to me, the point is that we got to get back to a point as a society where scientists do 2 things. Three things. One is admit their mistakes, right? If you like, I knew a guy who was working in molecular electronics. I'm going to leave the names out of this because some of them are still professors. Actually, they're all still professors. And one of them published a paper in Science Magazine, which is the publication for the American Association for the Advancement of Science, which is actually a very prestigious journal. And they published this paper. Actually, I'll just tell it to you. It's the Tour-Reed effect with Jim Tour and Reed over at Yale. So I guess I am going to rat them out because anybody who wants to do a Google search can find this. And what they did was they looked at molecules and go, oh, look, we got a switching effect. So you can make electronics out of the right molecules if you hook them up in the right direction. And the reason they wanted to do that was molecules are smaller than the data pathways at the time in computer processors. And if you remember, at the time, the only way we were getting faster computer processors was to make them smaller and smaller and smaller and shrink the data pathways down more and more. And every couple of years, you got a factor of 10 or something. And and the use of molecules was going to be a huge leap in another. So I think it was a factor of 100 or 1,000 at the time, and was going to be about as small as you could physically do. And then a whole bunch of money got spent. DARPA and some other agencies spent tons and tons of money on that research. And Reed over at Yale looked at it and went, they reran the same effect again with a much more sensitive set of instrumentations and went, oops, we made a mistake. Our original measurement was off a little more than we thought it was. It was actually a signal to noise ratio we were measuring. It had absolutely nothing to do with the molecules. You can get the same effect with or without the molecules in between there. So he published on the front cover of Science Magazine, oops, I was wrong. You got to give him credit for coming back and going, because this was like, they were talking like Nobel Prize level stuff here, right? And you got to give the man credit for coming back and being the one to disprove his own stuff and going, oops.
A lot of these guys don't want to, fess up. What can I tell you?
So that's one thing scientists have to do is get better at admitting mistakes. That is absolutely number one. Number 2 is uncomfortable truths. Okay. And Carl Sagan actually pointed this out, that as a scientist, it's not his job to tell you the result of a scientific experiment and have you be comfortable with that solution. It's just his job to tell you the answer and what it means. You might not like it, but that's what it is. Now, how much better would our lives be if politicians would handle things the same way? Right? You might not like the answer I'm about to give you, but this is what it really is, right? It would do wonders for us as a society, I think. But the third, I think, and this is paramount because this is something even Neil deGrasse Tyson, Neil does it for astrophysics and to a certain extent some other stuff on his podcast, but only if you listen to his podcast. Bill, and I put out the other day that we haven't had, I put this on Twitter, I think it was. And yes, I still call it Twitter. I don't care what Elon says. And
That itself is asking for a fight, but okay.
And I own a social media company that works with them, so I just can't bring myself to call it X. It's like I'm starting an adult theater or something. Anyway, did you see the new paint job on Elon Musk's plane? By the way,
I did not.
He has a big X on the side of his plane, and next to it has the initials GFY. And I sat there looking at it for 10 minutes, going, "What the hell?" So, oh, go fuck yourself. Okay. It's like he actually put that on the side of his plane. It took me 10 minutes to figure out what he was trying to say. So yes, okay, fine. It's X. I'm going to call it Twitter. But I put this out on Twitter that there's not really a modern day version of like a James Burke or a Carl Sagan who can come out and talk on any topic in science and kind of have it make sense to people. And so people came back with, well, Neil deGrasse Tyson and Bill Nye, the science guy. I'm like, okay, I hear you. Bill Nye doesn't take on complicated subjects. He takes on sort of the baby step science stuff that's kind of cute and fun to do demonstrations on, and that's great. And there's a very much a need for that. And Neil, to all his credit, he's great at talking about astrophysics and kind of breaking it down and putting it in language people can understand. But he's not the world's best at anything outside of astrophysics at doing that. And there's a lot of stuff outside of astrophysics that really needs to be discussed. And there's really not anybody out there doing that kind of stuff. So I think scientists in general need to take the time to explain why the stuff they're working on matters. Like, oh, if we're going to go off and work on gravitational field theory, who cares, right? Why are we going to go off and build these things to measure gravity waves? Who cares? They think, well, it's just astrophysics. No, this stuff can actually impact your life, right? And Neil, to all of his credit, he works at the Hayden Planetarium, right? So he works in a museum, and his job is to interface with the public and take what other people have done and explain it, and that's great. But I think even scientists in the lab need to get much better about coming out of the lab once in a while and going, hey, this is why it's important, right? It's not just so I can measure the mass of the electron more accurately. It's so that we can do the following things better, right? Those are the kinds of things that need to be explained. And that's not really happening. And I think scientists need to do that. But I think the general public also needs to be receptive to that, because it's going to take more than a headline. You're not going to be able to get it in something the length of a tweet, right? Because
it almost begs the need for science producers. If that makes any sense?
It does, because
scientist is great at, a good scientist is great at collecting the facts and the data and running their experiments, and but they may not be the best at communicating to the general public or to a large group at all. So where's a producer to come in and fill that gap in that translation?
And I think, and this, I'm going to actually show people something that normally people would not show, because I'm just that weird. So when you go into, nobody wants that. The people would pay me money to leave my shirt on. To be like, put it back on, put it back on. The kind of shape I'm in, you donate your body to science fiction, not to science. But no, what I mean is my Google Analytics.
Okay,
my YouTube Analytics. So on YouTube for a long time, I was focusing mostly on science fiction books and on Dungeons and Dragons, because I play. But I started focusing on Nobel Prizes and science and trying to explain what those Nobel Prizes actually mean to the general public and how they relate to one another. Like, this guy won the prize over here for this, and without that guy, this guy couldn't have won it, couldn't have done what he did. So, these guys are literally standing on each other's shoulders. And if you look, I was doing pretty well. I'm now up over 1,000 subscribers, but I just recently made that shift. A couple of weeks ago? You saw it when I made the shift. It wasn't that long ago I made the change. But if you look at it, I'm not doing anything different. It's still me. I was down here at like 840 something subscribers and pretty flat for a long time. And then I changed to the Nobel Prize stuff, and it's just like this steady climb. So yeah, I think there's certainly a need for producers, but I think there's also a thirst. I think some people actually do want this information. They're just not getting it out of anything other than documentaries from the 80s or 90s. And those are now, let's face it, kind of dated. Right? They're 30 plus years old.
Careful now, you're giving me hope for the human race.
But I mean, it's just me producing these things with my iMac and a laptop. Right?
Seriously, I'm saying the fact that hopefully your channel subscriber growth is indicative of folks that are actually thirsting for this type of content. Because, and even I'm guilty of it. We all just like to escape, typically content's for escapism and whatnot, not for actual learning purposes or, expanding oneself. So.
Yeah, and let's go watch some reruns of Lucifer because it's funny when Maze punches people in the face, right? But I do like that show, by the way. I was thinking of rewatching it. That's why I brought that up, because Maze is hilarious. I'm sorry, but anytime your bartender's a demon crossed with a ninja, I mean, come on, that's not fun about that. But I think there is an interesting desire out there in the public for this information, and I think there's a desire for it to make sense, because I think in the last 20 years, when scientists come out and explain it, half the time, me with a PhD and years in the industry, half the time I'm going, what the hell are you talking about? And it takes me a while to translate it, and I've got a background in the stuff, so how do you get it to be relatable for everybody else? And I think that's something that a lot more scientists need to take upon themselves. Sure. Especially if you're going to go off and ask for millions of dollars in funding a year, you need to be able to say, who the hell cares? Right. And if the answer is, well, it's just for general science purposes, that's great. But at least make that clear and don't oversell, because I've seen a lot of people, because I've been on both sides of it, where I've written proposals, and I worked with a guy at MIT who went on to be head of the National Science Foundation, a guy named Subra Suresh. I wrote a couple of papers with him. He was dean of engineering when I knew him, and he went on to be the head of the National Science Foundation. So I sat on, I'm going to write a proposal side to the National Science Foundation, and I've sat on, I'm going to read the proposals from the National Science Foundation that other people have sent in. And I think some scientists need to back down on, hey, I'm going to do this, and instantly this is going to be possible, right? Well, that's not usually the way it works, right? Because it takes years of engineering to make anything possible. And we need to not overpromise, right? Because overpromising and under-delivering is a bad thing. You need to promise what you can actually deliver on. And
sure,
that's what I've tried to do in my career for the last 20 years. So, and anyway, so that's kind of what I wanted to talk about today, was like, we do need to have that dialogue, but people need to be trusting of scientists and not want to lock them all in a warehouse and dispose of them. Because I had somebody threaten that too. Somebody actually brought up Hitler and Germany and chemistry and the what do you call it? The prison camps. So like, well, they used science to kill the. I mean, I get it. Can we all agree that Hitler was the biggest mistake ever, and we're not going to repeat that one? And yes, he had scientists working for him.
Let's tie science to the evil only, and not the bad, not the good. It's factual. It doesn't have a purpose. It isn't trying to do good or do bad. Is what it is.
And how you use it, that's different.
Exactly.
But you need to use it properly. But the science, underlying science itself, it doesn't care if you're good, bad, or indifferent, right? It's like social media. Social media has been a great thing for connecting the world. It's been a terrible thing for self-esteem of teenage girls.
Right? Absolutely. Yeah. That's a whole separate video. That's a video on its own, right? I mean,
yeah, it is. But nuclear power, it's a terrible thing in that it built bombs. It's a great thing that you can build a reactor. Right? Those two things are two sides of that same coin. So I think science is science. It doesn't give a shit how you use it. What you need to do, general public, is become good at using it for good instead of bad. And what scientists need to do is get much better at explaining the upside and the downside of it. And that's why I think I miss Carl Sagan and people like James Burke as much as they. And James is still kicking. He's doing stuff. He's in his late 80s. He had a series come out last year. But if he's in his late 80s, how many more of those is he going to do? Right. He still seems energetic. I heard him on a podcast the other day. He's like, I will do this until they put me in the ground. I'm like, great. And I hope you do, because you're great at it. But, we need the next generation, people like me, and I'm working on it, people like me to kind of stand up and fill that mantle in a more appealing sense.
Well, keep producing that scientific data content. Okay.
That's right. And if anybody misses if you haven't seen it, I am on YouTube. Just check it out. Just at Timothy M. Holt. I'm pretty easy to find. And if you ever want to hear from Doug, go sign up for a free account on One for All. It's o4a.com.
Thanks for the plug.
And it will boost the crap out of your social media, because what we did, and I'll even throw it up on the screen just so people can see.
Again, a tool for your use. I would prefer I'll use it for good, but I don't control that. We're just trying to help people grow their channels and preferably their businesses.
Yeah, it's an interesting tool. So it actually uses physics or uses a physics tool and applies it to social media. So what we did was we built a tool that does all kinds of interesting stuff. I really prefer red wines and mostly a good, I don't know, Cabernet. And yeah,
Merlot, I'm gonna have to drop off the stream right away.
no, I'm never going to say Merlot because I'm not freaking drinking Merlot. So what we've got is this little hashtag button here, and this runs a bunch of science and AI stuff called predictive analytics to go through and read your post for you and figure out what hashtags to use. And look, I love it. See, the word Sauvignon is not in my post, so the system's smart enough to realize you should hashtag Cabernet Sauvignon, not just Cabernet. And it'll find the right hashtags for you to get your message seen. And what that does is it boosts the crap out of your engagement rate and helps you grow. And it uses a large language model along with the predictive analytic that we came up with internally. So basically a bunch of science to figure out how to help you grow. And the result of that is I've got a 20+% engagement rate on YouTube because all my stuff runs through there. And last time I looked, I was up over 6% on Twitter. Yes, Elon, it's Twitter, and I know I'm live streaming to your platform. So when you monitor me, I don't care. We can
That
have
being
that.
said, you increased your your following to over 10K users in what, less than a year?
12,300 now.
Yeah, in over a year. But I mean, in less than a year, I think you shot up to over 10.
Yeah, about a year ago, year and a half, a little over. It took less than a year to go from like 1,800 to over 10,000.
Yeah.
And it was all organic growth. I didn't run paid ads. I just posted with the right hashtags, and my engagement rate's significantly over 6% right now. Wow, really?
The same can happen for you and your channels using O4A.
Yeah. And you get 2 months, and you get 2 months for free. So use it and abuse it for 2 months. So anyway, that's all I had today, everybody. Thanks for stopping in. And we'll see everybody on the next one.
Yep.